Alright, so here we are with the Chapter 4 test review. Alright, so we're going to convert degrees measures into radians and radian measures into degrees. So let's see, these are our radians. Over here we have degrees, degrees, and then radians. So in order to convert from radians to degrees, taking a look at this, all we do is take our radian value, multiply by 180 over pi, and then we get our degree. So times 180 over pi means that we're going to get the pi's to cancel, so that's not so bad. And 5 times 180 divided by 2, so it's technically 900 over 2, or 450 degrees. Alright. The next one is degrees, and so we're going from degrees to radians. So we're going to take the degree value and multiply by pi over 180. Since this is just a number, it's technically over 1. So that means that we get negative 135 pi over 180. Apparently if we divide the top by 45 and the bottom by 45, we end up with negative 3/4. Sorry, 3 pi over 4. Alright, and then the next one is 78 degrees. I think I'll move it over here. So 78 is in degrees, technically over 1. So just like the previous one, we have to multiply by pi over 180. So we're going to get 78 pi over 180. To simplify, we're going to divide the top and the bottom by 6. And we're going to end up with 13 pi over 30. The next one is pi over 12. And so we're going to multiply, since it's radians, by 180 over pi, just as we did in the first one of this section. And if we do that, we're going to cancel the pi, meaning there's 180 over 12. 180 divided by 12 is 15, so 15 degrees for the answer there. Alright, the next one they want you to use the unit circle, because notice they're saying without a calculator. So we need the y value, because that's what sine is telling us, of 30. So going to 30 degrees, here it is, y value is 1/2. Next one, we want tangent of negative 135. Remember, tangent is, of course, sine over cosine. So we need the y value over the x value of negative 135. So positive 135 gets us here. So negative 135 would get us here. And we need the y over the x. So negative square root of 2 over 2 over negative square root of 2 over 2. So just a positive one for that one. The next one, we want sine of 5 pi over 6. So let's see, where's 5 pi over 6? Over here. And remember, we want sine, and so that's the y value. And I've already forgotten it. So 1/2. Alright, and the next one, we want secant. So remember that secant is actually 1 over cosine. So 1 over cosine of negative pi over 3. Remember, cosine is the x value. So we want negative pi over 3. Alright. So if pi over 3 is up at 60 degrees, negative pi over 3 is here. And we want the x value, so that's 1/2. So we want 1 over 1/2, which is actually 2. Alright, next one is cosecant, and so that's 1 over sine of 270. So 1 over the y value at 270 270 y value is -1. So 1 over -1 or -1. And then the last one is cotangent, which means that we are going to have cosine over sine of -90. So the x value over the y value of -90. So positive 90 is this way, negative 90 is this way, and we want the x over the y, so 0 over -1/2. I'm sorry, 0 over -1. And so that means that we're going to have 0. Alright, so the next one, we're going to evaluate exactly all 6 trig functions of this angle. Okay, and we're going to use the reference triangles and not our calculator. In this first one, since that is on the unit circle, I'm going to go ahead and get some of them from there. So just so that I don't have to waste so much time, I'm going to write sine, and then cosecant, cosine, tangent, secant, and cotangent. Alright, so sine is our y value, and we want at -pi/6. So pi over 6 is up 30 degrees, but -pi/6 is down here. So our y value is -1/2. And our cosine value is square root of 3 over 2. Alright, and so to get tangent, we want sine over cosine. So sine over cosine is -1/2 over square root of 3 over 2. So that actually means taking away the 2's, we get -1 square root of 3 over square root of 3. Of course, we don't love having square roots in the denominator, so if you look at the answer key, it will probably actually say negative square roots of 3 over 3. But that is okay with me, so -1 over the square root of 3. And then we flip them for the other ones. So this one is going to be negative square root of 3. We don't flip the sign, just the fraction itself. 2 over square roots of 3, and -2. Alright, the next one is 19 pi over 4, but we need to subtract a few pi's to get down to something that we can recognize. So if we subtract 8 pi over 4, which is 2 pi, a revolution, we get 11 pi over 4, but subtract another one, and we get 3 pi over 4. It's definitely something that's on the graph. And so just as we did before, we're going to do sine, cosine, tangent, cosecant, secant, and cotangent. So 3 pi over 4, so over here, 3 pi over 4. And our x value, so our cosine is negative square root of 2 over 2, and our sine is square root of 2 over 2. So negative square root of 2 over 2 and square root of 2 over 2. Meaning if we put one over the other, they're the same thing, but one of them's a negative, so that's tangent. Cosecant is the flip, so 2 over the square root of 2, and then -2 over the square root of 2 for secant. And then cotangent is going to be the flip of -1, so -1. Alright. Then we have our next one, 135 degrees. So going back to our unit circle, 135 degrees is the same as 3 pi over 4. So we're going to say it's the, oh wait, it's negative. So that's over here, which means that the sine and the cosine are the same number this time. So sine, cosine are both square root of 2 over 2, negative. That means tangent is the same thing over the same thing, or +1. The cosecant is the flip, so -2 over square root of 2. Secant flips cosine, so 2 over square root of 2, negative. And cotangent flips the number 1, so it's the number 1. Alright, and then we have 420 degrees, which is weird, so we're going to subtract 360 and get 60. So we're actually talking about 60 degrees, which on the unit circle is up here. So our cosine is a half. Our sine is square root of 3 over 2. And our tangent is those two over each other, so the square root of 3 over 1 technically. So cosecant is flipped. Secant is flipped, so 2, and cotangent is flipped, so 1 over the square root of 3. Alright, the next one's find all 6 trig functions. Ew, very exciting. Okay. So we are going to find sine, cosine, tangent, and they're doing it of this one, so as much as beta is there, we're looking for alpha. Alright, so we're missing a hypotenuse. So quickly, if we go through, or you can remember that the Pythagorean triple is 5, 12, 13. So I know that this is 13 for my hypotenuse. I also know that this is my adjacent side, this is opposite, and this is hypotenuse. And so SOHCAHTOA is going to help me figure this one out versus the unit circle. So sine is opposite over hypotenuse, so 5 over 13, and then the flip for the other one. Cosine is adjacent over hypotenuse, so 12 over 13, and then the flip for secant. And then tangent is opposite over adjacent, so 5 over 12, and then the flip for cotangent. Alright. The next one wants you to use a right triangle to determine the values of all the trig functions, where cosine of theta is 5/7. So again, we're going to need our list. And so if we draw a triangle to help ourselves out, remember that cosine is adjacent over hypotenuse, and so that means the adjacent side to this theta that I have is going to be 5, and the hypotenuse is 7, and we don't know what that opposite side is. The Pythagorean Theorem says that if we calculate this with an C value, and this with A, and this with B, we're going to be able to solve 5 squared plus B squared equals 7 squared, or 25 plus B squared equals 49. Or subtracting 25, we're going to have B squared equal to 24, which does not square root nicely, so the square root of 24 is your B. Alright, so that means when we're setting this up, sine is opposite over hypotenuse. And so we've got opposite square root of 24 over hypotenuse 7. And let's say that you look at the answer key and that's not what it has. If you find the decimal equivalent, you'll notice that they are the same numbers. It's just that they most likely simplified if it's different. Reduced their radical. Alright, so 24 over 7, and then of course the flip for cosecant. Cosine is adjacent over hypotenuse, already had it, and so the flip for secant. Tangent is opposite over adjacent, so square root of 24 over adjacent 5, and then of course the flip for our cotangent. Alright. So, next one is going to be 39. So in number 39 we need to solve in order to find out what the rest of the sides are. So solve just means find the rest of the values. So in number 39 we're trying to find out what is the value of A, We also want the value of B. We don't have that. We do have C, because C is 15 as it's given. Then we have alpha, which is 35. Oh, sorry, we'll just call it A. And we also need B and C, the angles. And they're telling us that A is 35 degrees, so that's what we have. Oh, and C is 90. Okay. So this is when we go back into trig and we say, okay, well, if this one is 15 and this one is 35, I have the hypotenuse and I want the opposite. So that's sine, right? Sine of 35 is going to equal my opposite over my hypotenuse, which is 15. And so to solve, I'm going to pretend it's over 1, multiply sine of 35 times 15, divide by 1, which isn't going to change much, and get an A of, make sure you're in degree mode, degree, because I put in 35 degrees, not 35 radians, and so we get 8.6036, and so A is 8.6036, whoops. Alright, and then the next one, we're going to do the same sort of thing, only now I'm trying to find the adjacent side, given the hypotenuse. So I'm going to do cosine of 35 equals B over 15. But of course that's over 1 as well, and so we'd multiply the diagonal. So cosine of 35, again in degree mode, is going to make 12.2873. We could have also used Pythagorean Theorem there, either way. And then this last one is going to come from the fact that 180 minus 90 minus 35 is going to equal angle B. So 55 degrees. And that's number 39. Alright, same idea for number 41. So number 41, we have different values now. We are told that this is 48 degrees and A is 7. And so if we are up here at angle B to start with, because that's the one that's given, if we want to find, we are given A, so A is 7. If we want to find B, we're going to use the opposite over the adjacent. So we're going to use some tangent. Angle A we don't know yet, but angle B is 48, and angle C, of course, is 90. So to solve, we're going to do tangent of 48 equals B over 7. Same way of solving, divide by 1 on the one side and multiply diagonally. So tangent of 48 degrees times 7 leaves you with a B of 7.7743. And then our C value is the hypotenuse. And so we have adjacent and hypotenuse, so that means we're going to do cosine of 48 is going to equal my adjacent side, which is 7, over hypotenuse, which is C. This one is going to be a little bit different because we're multiplying this way and then dividing by our last digit. So I'm going to do 7 times 1 divided by cosine of 48, and that's going to equal C. And so C is 7.1 divided by cosine of 48. So 10.6108. And then our last digit of A is going to be from 180 minus 90 minus 48. So 42 degrees. Alright, and then the last one in the first half of the review here is number 43. And in 43, let's erase all this good stuff. In 43, we're given that B is 5 and C is 7. And so Pythagorean Theorem can get us what A is. So let's see. I'll write it all out. Of course, C is 90 degrees. A, we don't know, but B is 5 and C is 7. And so if A squared plus B squared equals C squared, A we don't know, but B is 5 and C is 7. I feel like we did this one just recently. So A squared equals 24. So A is the square root of 24, which I'm not going to get a decimal for. Alright. And then to solve to get our angles, we have to do our inverse. This is the first inverse we'll do. So let's say that we want to solve to get A. A is over here. If we want A, we are given the hypotenuse and it's adjacent. So that means we need cosine. So cosine of this A that we don't know is equal to adjacent 5 over 7. And so in order to solve this, we need to take the cosine inverse of the left side. That will leave us with A. And the cosine inverse of the right side. And that will get us, as long as we're in degree mode, the angle measure. Cosine inverse of 5/7 is 44.42 degrees. And so, if we take 180 for the whole triangle, minus 90 minus 44.42, we're going to get 45.58 for the other angle measure. So, kind of a lot going on there, but totally doable. Okay. Alright. So that's the first half of the chapter 4 test review. So we went from 1 to 43.